Hey guys, welcome back to another Default Cube CG Matter tutorial, and what this video is it's basically a merge of the last 7 Blender procedural node tutorials into just one video that I consider level 1. So everything here is pretty much everything before texture coordinates, and this video is for anybody who just kind of wants to watch the whole thing in one swing and just do one after another, which kind of makes sense because I made them in a certain order so that they flow together. So this is the best way to watch all the level 1 content. And before we start, this whole video, I just want to mention two things. First of all, I'm just literally merging these videos one after another, so there's going to be a tiny drop in quality, nothing noticeable, still be 1080p and everything, because I have to re-encode and all that. And that also means that each one has an intro and an outro, and those are going to be preserved. So hopefully that's not too annoying. If it is, you can always skip through the video, but I recommend watching the whole thing. And second of all, I just want to say this is a free course. I mean, I'm going to keep making it. This is a level 1 free. So if you want to support or donate or whatever, Patreon is the best way to do that. And again, it's a free course, so at your discretion, it's up to you. Or there's also an email in the description if you want to donate or anything. So I'm just saying that because it's free. I wouldn't be doing that otherwise. And you're also going to see those Patreon plugs at the end of each tutorial. But again, free course, best one on Blender procedural nodes that I've seen. So I'm really proud of this, and I hope you enjoy the course. Hey guys, welcome back to another Default Cube CG Matter tutorial. And as the title probably shows, we have started the procedural node series. So this is episode 1, and we're just going to go over some getting started stuff. So don't expect a lot of math and a lot of node stuff right off the bat. I'm just going to show you what procedural even means and, how you kind of navigate Blender to even start using nodes. So if I can get this over here, you can see that I want to start off with some reference material of just what is possible. So I'm on the Twitter of Simon Toms. He's pretty much a legend with this kind of stuff. So let me show you some results that are possible. Not necessarily that we can make, but that are definitely possible. So you can see that, first of all, what you have to understand is all of these are just spheres in Blender. And basically everything you're seeing is just a bunch of math he threw at this to get these results. So this is like top of the line stuff. This is just what is possible. And you can see that all of this is animated as well, which we're going to get into. So that's part of what it means to be procedural, that you can animate everything about it. But these results are just crazy. So big shout out to him. He doesn't need a shout out. Everybody knows him. So basically, I think we're going to do some of these, at least like the theory of some of these. We're not going to make the results this good, but like doing stuff like gas and atmosphere and all that, we're definitely going to do. And then also this hedge maze, I think we can work our way to the labyrinth as well. So these are just some of the crazy results that are possible, but yeah. So let's just talk about what procedural even means. So here we have a normal Blender scene with a plane and a truck outside without any material. So this is just a black plane. I mean, it has a material, but nothing's connected to it. And normally what you're probably used to is using textures. So for example, I have this texture of a circle. It's just a JPEG or a PNG, and in this case, I think it is a 1K texture. We can check. So we have 1000 by 1000 texture, PNG, etc. Has an alpha channel, doesn't matter. So this is just a texture that you could probably make yourself or download online, and when we take this, we can plug it in to our surface. And again, you don't have to understand what any of this means. I'm just talking over some very, very general, without knowing anything theory. So basically, we have a node here called circle texture, which is containing our texture. We plugged it into here, and now you see it on the plane, and it's a circle. But the issue is we can't really control anything about it because we just took an image and slapped it on there. Well, not only can we not control it, but when we zoom in far enough, you can see that this circle is actually jagged. Why? Because this picture has a limited resolution. And the more we zoom in, the more apparent that is. So it seems like a limitation of textures is you just get what you get, and that means you're probably going to have to buy some textures, or you're going to have to make a bunch of them just so you can cover every scenario. And then also, the resolution matters, and you're taking up space on your hard drive, especially if you go high resolution. On the other hand, we have this node that I made, and if we look into this node, it's actually a bunch of nodes. It turns out that this thing I made is actually a group of nodes. Don't worry about it. When I take this and plug it in, it also gives us a circle. It almost looks exactly the same, except you can see when I zoom in, the curvature doesn't look jagged at all. It just keeps going. And that's because this circle is not made with any textures at all. It's all mathematical. So not only does this not have any resolution issues because it has infinite resolution, but you can see that this node also has a slider that I made. What does it do? Well, it just controls the size of the circle, and that's like not that big of a deal. Like technically you can take a circle texture and scale it, so you can do that kind of operation, but you could add tons of more controls that let you do other stuff with more complicated shapes. So really what we have is a procedural approach and a texture approach. And once we get into more sophisticated stuff, you could just take this node and do a bunch of stuff with it. So let's say we duplicated it. Again, don't worry about any of what this means. Now I'm going to view this one and make it a bit bigger, and we can just combine these using some math. So let's just take this one, do some subtraction or something, and let's play around with the size of this. And now you can see that with a very simple edit, we have made a torus, which is kind of like a 2D donut, if you want to think about it that way. And we can control the outer ring, the inner ring, and again, this is procedural. And you could, again, do this with textures, but now we have a infinite resolution donut. So you can see how this stuff kind of scales really quickly. We went from a circle to a donut, which it is a bit more complicated. Okay, that's fine, but what if we want to do something that's actually more sophisticated? Well, there is room for that too. You can see I made a node over here called a tiler node. And if you look into this, it's not that much. It's some math nodes, some other stuff. Don't worry about what it means. But what we can use this for is, let's put our circle in here. And then we are going to take this and plug this into this mystery vector socket that I haven't explained. And now you can see we have a bunch of random circles. And now we have many, many more. And this is completely procedural, infinite detail on all these circles that we can zoom into. And the best part is we can actually animate this kind of stuff and get different seed values and kind of control where we want the circles, or you can fill everything in. Maybe make this a bit smaller so we have less of them. And now you have, if we make this circle a bit bigger, now you have some kind of fancy floor texture. So really you have a ton of control over this stuff. So really when you think procedural, think something that is basically does not have any textures. That's the best way you want to think about procedural. If it doesn't have textures and you can control it all mathematically, it's procedural, and the benefits are you're not taking up space on your hard drive, and you have controls if you had controls, and you have infinite resolution. So that's just kind of the intro for what it is we're going to be talking about. And let me start a new Blender scene. And I guess we shouldn't save this, that's fine. The only other thing I want to talk about is how we even get to the menu I was in before. So I'm going to assume you've never touched Node, so we're really going to start from the super basics. So luckily, this is actually very simple because you can just, over here we have our workspaces, you have layout, modeling, etc. All we have to do is click shading, and we're in this pretty much the same menu we were in before. So that's pretty much the tutorial for that. You can also, by the way, really what we're interested in is this window over here, the 3D viewport we already had. But this window is called the shader editor, or sometimes just the node editor, but we'll call it shader editor. And if you don't want to go to the shading workspace, you can just open up a new window like that. You just drag that up. And then we can select, instead of 3D viewport, we select shader editor, and now you have pretty much the same thing, but now it's in the layout workspace, and you can also do this sideways. So let's do it like that. Normally, I'm just going to be clicking shading, so that's how you get to the menu that I'm usually in. The only other things we need to take care of before we get started talking about nodes and all that is some settings. So go to Edit, Preferences, Add-ons, and I want to make sure that you are using a special add-on called Node Wrangler. So you just type it in, it's going to be there, and for you it's probably disabled if you haven't enabled it before. Make sure you enable this add-on. We are going to be using it literally every tutorial. And what it's going to let us do is a bunch of cool stuff. So for example, normally if you have a node, and a branch between these, we'll talk about what all that means. The way you disconnect is you just pull it off, and then you can connect like this. And when you have a lot of nodes, that takes a while. So what Node Wrangler lets you do is something like that. And then you can connect like this. So it's kind of like shortcuts for these kinds of things. And especially if you have two different nodes, do you really want to do it like this? And if you're zoomed out, it's kind of hard to do that. Or would you rather just connect really quickly like this and disconnect? This is just a faster way to work. And there are a ton of other commands and things that Node Wrangler lets you do. But I'm not sure if this one, what I'm about to do, if collapsing a node and hiding everything except what we're using is a Node Wrangler feature, but it might be. But either way, make sure you have Node Wrangler enabled. And the other thing that you guys might care about is I think there's kind of a divide between people who like curved noodles and people who like straight ones. And I'm just going to show you how to switch between those. So again, edit, preferences. This time it is in themes, and then you go to node editor. So this time not shader editor, but node editor, whatever, same thing. And we can control pretty much a lot of these things, like what color it's going to be when it's highlighted, etc. If you see the bottom setting, it says noodle curving, and you can change that. So now, if it's 0, you have perfectly linear straight lines, and I think a lot of people, I think Simon Toms even likes to work this way. Or you could do, I'm sorry about all the stuttering today. Or you could do something with a lot of curving, which kind of gets ridiculous. So I like to keep this at around 4. And really, now that you know what procedural means, you know how to get to this workspace, or maybe just go to the shading workspace is the faster way to do it, and you also know about the add-on and everything, I think you're ready to probably get started on the second tutorial where we actually talk about stuff that matters. And we're just going to be talking about some super simple stuff like value, color, etc., how to control those, and generally how to work with nodes. So there you go. That is the first part of this tutorial. Hopefully you enjoyed it. And again, it's just a preview. I know we didn't go over much, but tomorrow I will come out with the second tutorial, hopefully. I'm not going to rush it. See you guys. Hey guys, welcome back to another Default Cube CG Matter tutorial, and this is part 2 of the procedural node series. And in the last video I said I'd be talking about values and like RGB, and these are all just different kinds of nodes we'd be talking about. And it turns out that that probably doesn't make too much sense, because that is actually making and modifying a material where we probably don't already know what materials are. At least I'm assuming you don't, because I'm going to assume that you know nothing to begin with. And I actually already just recorded this tutorial. It was very, very good, but I forgot to show my mouse cursor because OBS does not show it by default for me. So I'm a bit mad, but that is fine. So hopefully, let me make sure. Can I see the cursor? Yes. Okay, so this time we are in business. And I don't have Blender open because, you know, whatever. So we are going to be using version 2.81 again. Probably at some point in the series, it's going to transition to 2.82, which has some differences in some of the math nodes and all that, which isn't important right now, but I'm just letting you know. So 2.81, let's make that full screen. And can I still see my mouse? It was such a good tutorial, but this time I'll probably be able to say everything more clearly. So, assuming you already saw the first tutorial, because it's a series and it would make sense that you did, you probably already have everything set up, but I just want to make sure you have two things. Go to Edit, Preferences, Add-ons, and make sure that you have Node Wrangler installed. Again, we already talked about this. If you have Node Wrangler, you're good in my book. And then the only other thing we talked about is how to get the shader editor window, which is where we're going to be doing all our work. And you can either do that, again, by opening up a window, going to shader editor, or what I like to do is just hitting this button, shading workspace, which gives us everything we need. And that pretty much covers the first tutorial. So why even watch it now? Okay, so again, like I said, we're not going to be really tackling material creation because we need to talk about the material system, which is this whole system in Blender that kind of tells you what objects are, do objects have materials, what are materials made out of, and it's just all these layers that go down and down and down. So let's try to keep it simple to begin with. So we have this default scene, which has a default cube, and that cube has a material. You can see we already have nodes down here. Okay, well, how do we know this has a material? Well, when we select our cube, you're going to see it says material over here, and in our dropdown, we already have a single material. We can take this and give it a name. It can be any name. It can be dumb name, which isn't that creative. I'm gonna go with first ever mat, as in first ever material, and this still represents the same material. No matter what name we give it, it's still that material. So the way you want to think about this is we have an object, being the cube, and that cube has a material, and it's called this, and that material is effectively this node graph, which means, as you might expect, if we change the instructions, the node network that makes up the material, it's going to change the material and therefore look different on our cube. It's pretty simple. So again, we don't know what any of this really is, but you do see something called base color, which has a white color, and you might expect that we can change this. And you see, we turned it red, and the whole ripple effect takes place. The node network has changed, which fundamentally changes the material itself, which changes this cube. We can duplicate this, so now we have two cubes, and we can change both of them. Well, why is it changing both of them? Is it because it's a duplicate? Well, what it is it's because both of these objects, both these cubes, which are separate objects, you can see they have two different objects, cube 001 and cube in the outliner. They're two different objects. They both have the same material, which means if we change the node network, it affects both of them. But can we have two objects have different materials? We can. All we need to do is add more material so that they can have different ones, because right now if you have two objects, one material, you kind of have no other option. So how do we make a new material? In our dropdown, we only have one option. To do this, there are a bunch of ways, but the easiest way to do this is you hit this button right here, which is new material. So now we have first ever mat 001 and first ever mat. I'm going to give this another name, like why do I need to record this again? And you can see that now we have two different materials in our dropdown, and they kind of look the same, actually exactly the same, like these node networks don't change. And the reason for that is it's not a glitch, Blender is working fine. It's because we duplicated the material. When you create a new material, it will just pull from whatever material already exists, and therefore they already have the same node networks. But if we take this one, this why do I need to record this material, and change the color, you can see now this cube is blue. But why did this one not change? Well, this cube, when it's selected, shows that we have why do I need to record this material, and then this cube has a first ever mat material. So they're different materials. So if we want to edit this one, we go to this one, change it to blue, this one, change it to yellow, etc. And of course, at any time we can switch. So with this one, we can switch back to this. So whatever you select from the dropdown will be the active material. And it actually gets a bit more complicated than that because we've talked about different objects having different materials. But can one object have multiple materials? Can it be both yellow and blue at the same time? And that's where it gets a bit confusing. And it actually has to do with something called material slots, which is just another layer of abstraction, because Blender loves that. And you can already see that in our shader editor, we have something called slots. So you might expect that we can do something with this by, creating, subtracting slots, whatever. So let's talk about that. So let me just delete this. So right now we have a single object with two different choices of materials. One is blue, one's yellow, etc. But how do we actually have two different materials at the same time? Well, I was kind of lying to you when I said that it's as simple as object has a material and that material is the node network, because it's not that object has material. Object has a material slot. It's a container. That container has a material, and you can have multiple slots, and those all go to the object. So it's kind of like you have a list of node networks that are sent to the object. Well, how do you see these? Well, luckily for us in the shader editor, we don't only have, the shading workspace, we don't only have the shader editor and the 3D viewport, we have this properties window, which again is in layout. So if you pull up this window, you still have this properties, so you're all good there. But this properties window actually has a materials tab, which has a lot of the same options. So for example, you see this is blue, they're all linked together, but we can take this and change it to red, and you can see everything synced there, and the names are synced, etc. But what you're going to see is a material slot. So this is a slot, and inside the slot, we have first ever material. And we can pick different materials to be inside the slot, and we can add different slots. So now we have two slots, and let's say for the second slot, we want the other material. Now at this point, you might think, oh, this kind of looks like a layer system. So we have two different layers, each with a different material. Why don't we bring this yellow one to the foreground? And then you do that, and you wonder why the cube is still red, even though it's in the background. And that's because slots are kind of confusing. It's not what you'd expect. It's not like a layer system where you can make something in the foreground and make it transparent so that both are seen at the same time. What a slot is, the way you want to think about it, is a slot is a selection. Meaning that right now, this slot, which is in the second down the list, this slot has the full cube selected. This yellow one has none of it selected. Okay, so what do we mean? If we go into edit mode, you're going to see these three buttons appear. It's not going to be in object mode. You have to go to edit mode. And I'm just going to deselect everything. With this material selected, which again is the entire cube, we're going to click select, which is, it says select by active material slot. We click this, And now the whole cube is selected. What did it do? It basically selected every single face that had this material. So let me deselect everything. Now we're going to do this yellow one, select. Nothing happens because none of them are selected. So the way Blender really works is an object is composed of a bunch of faces, and it's that each face of an object can only have one material, but since most objects have more than one face, you can have a bunch of different faces with a bunch of different materials. So one material per face, but if you have more than one face, you can have a variety of materials. So what do we mean? So let's just select a face like this top one. Again, all of them are red. I'm going to select this top one. And you can see no matter what I select, so I'm going to select this yellow, no matter what face I select, it's going to automatically switch over. So I'm going to select a face, then I'm going to switch materials, and you see it didn't actually turn it yellow. What we have to do is once we have everything set up, we click Assign. So now we have assigned a selection. So now we have one object with multiple materials, but again, each face has one material, as far as I know. And if we go back into edit mode, now if we select our yellow material and click select, it's only going to highlight the top face, whereas this red one, we click select, it's going to do the other 5. And we can make this a bit more complicated, so we can just select these 3 and do an assignment of our yellow. So now half the cube is yellow, half of it's red, etc. And even from this properties window, which is in the materials tab, we can also, again, add more slots, but also create new materials. So you don't necessarily have to do it here. We can also do it over here. So let's add a new one. We'll call it, we don't have blue, so let's make one blue. And you can see the slot now has the blue material, but nothing changed because it just duplicated our yellow material. So blue, yellow, they look exactly the same. So if we turn this to actually blue, now you see that everything works out. And let's say that we wanted a blue and yellow cube. What would we need to do? Well, the blue can stay blue and the red needs to become yellow. So with this material, which again has the selection of these 3 faces, what we need to do is just switch this over to yellow. So I think at this point we are starting, or at least hopefully understanding the hierarchy we have. We have an object is composed of faces, and each face is basically a selection represented by slots, which are containers for materials, and each slot's going to have a material which is a node network, which when you say it out loud makes it sound pretty confusing, and I guess I guess it is pretty confusing, so I think you'd be right about that. And really, the rest of this series is the art of taking a material and making it into what we want. So now that we know how the material system works, it's all about actually messing around with these nodes. So, you know, something more complicated than just taking the color and like switching it up. I think we can do better than that. This camera switching setup is quite something. The only other thing I want to talk about, hopefully I'm not forgetting anything. By the way, you can also do all this slot stuff we were talking about. You can do it from here. As you can see, we have different slots, and you can see it switches. If we go to slot 1, you see slot 1 is blue, so it toggles over to our blue material. And then, you know, same thing for this. So if we change this one to red, we're now in slot 2, and it's going to be red, and everything's linked is what I'm trying to say. The only other thing I want to go over is material deletion, which is actually also a bit confusing. So you might expect the way you delete a material, it's right next to create material. You go to this X to unlink data block, which is just digging into Blender's data block system, which is great, but very confusing. If you click this X, you're going to see that it removes the material, but it's still in this list. So first ever matte, delete, it's still there. What's up with that? And it has this 0 next to it. Basically what it means is when you click the X, it unlinks the data block, and what should happen is when you close your Blender project, assuming it's saved, you close it, and then you open it again, only then will it actually be deleted. And the 0 basically means that nothing is using that material, and you chose to delete it, and therefore it's going to be gone when you restart your Blender project. You close it, you open it. And, you know, that can be a bit off-putting because you can't delete something. Even if we, you know, do it on all 3, we're basically jumping around over which one has the 0. How do we actually delete something without restarting Blender? The way we do it is, again, it's all this stuff with data blocks. So what we have to do is in this outliner window, you can hit this button, which right now is on view layer, I think. And what we can do is instead of that, we can view the Blender file, which is just a list of assets that make up your Blender projects. And now we're really getting into this hierarchy stuff. What you can do is in these assets, you're going to see, sorry about the face hopping around, it's automated. What you can do is go to materials, and you see we have 3 materials, which makes sense. We open it up and we have our 3 materials. If you right click one, we can do all this stuff with unlinking, whatever, but you can just flat out delete it. And you can see it's gone from here, and now our drop down only has 2. So let's just keep going with our deletion. So just right click, delete, and now we have nothing in our drop down. Sorry about the voice. So yeah, that's how you actually delete something without restarting the project. And then to create new stuff, you can see it kind of has some kind of white default material. It must, because clearly I have no material selected, so it's defaulting to something. We can create a new material, which will give us this simple node network to begin with, and then we just modify it in the same way as before. So that is pretty much the essence of everything you need to know. You can see that it only showed up on these 3 faces because even though we deleted the material, the material slots still exist. So if we want to have everything be red, we can just delete the first slot, which is going to make everything be red, because when you have only one slot, it's going to default to every face having that material. So there you go. I feel like you now know the hierarchy, and I understand that it's a bit confusing, but you have to understand the material system before you talk about materials. So in the next tutorial, I think now we are ready to talk about actual nodes, so not just, how do you handle materials, how do you make a material? And we're going to talk about some very simple nodes, and I can actually give you a taste. We're going to talk about nodes that aren't as crazy as this one over here. It has too much stuff going on. We're going to be talking about some simple nodes like the value node and color, and we're going to be talking about the bare basics and then building up. So hopefully you understand everything we talked about so far. So really the rest of this procedural node series is about making node graphs, node trees, whatever you want to call this, which again is the material. The material is this node graph. The material is put in a slot, which represents the selection on your objects, and all that is sent to the object. So hopefully all that is now understandable, and hopefully I recorded it correctly this time. So yeah, it's rough. If you want to support this tutorial series, and more so if you want to support me, the only way to do that is via Patreon. Your likes, your subscriptions, your dislikes, doesn't matter. I need patrons. So if you want to donate, that is the place to do it if you want to help me out. Thank you for watching. Hopefully part 3 will be out tomorrow. I'm not sure about that. I don't know if I'm going to record another, especially after this. I can't think of the word now that I'm at the end of the video. This scarring event. That's dumb. Thanks for watching, guys, and I'll see you in the next one. Hey guys, welcome back to another Default Cube CG Matter tutorial, and today we are doing part 3 of the procedural node series. I know it took a while for me to actually sit down and record this, but that's because I was waiting for a new microphone. And now everything should be working. Yes, I had some recording issues earlier, so I want to make sure everything's going before I invest a lot of time. And like usual, we're going to be using version 2.81, and I'm going to keep pointing that out until we switch to a different version. And yeah, let's make that full screen. So what are we going to be talking about today? Well, a while ago I said I'd be talking about value, color, maybe a bit of math, and that was supposed to be part 2. But of course, we had to talk about the material system, so today we are doing all those things. So in the first episode, we learned that the way to get to the shading workspace, or just to get the shader editor in general, is either to, I'm going to stop repeating this after a couple episodes, but again, you can either open a window, go to the shader editor, do your thing, or just hit shading workspace. And this time for real, I need you to have, it wasn't important last episode, but for real, in add-ons, make sure that you have Node Wrangler, because today we're actually going to be going over shortcuts that depend on it. Okay, so we're in the shading workspace. We have the default scene with the default cube, which has a default material. Again, remember, our cube has a bunch of faces. Each one has the assignment of this material, which we can name anything. I'm just going to call it default material. And you can see that when we change this color, it's actually changing this node network, which is the material which is on the surface of the object. We already went over this. I'm not going to keep talking about it. So Today, I just want to talk about how this shader editor works in the first place, and then we're gonna kind of get rid of this big node and replace it with something that we can actually manage. But before we do that, let's talk about some basics. So you're in the shader editor, and you see me, zooming in and out, navigating. How do I do that? Well, pretty much all of Blender is pretty connected with its hotkeys. There's still a couple exceptions to that, which they need to get to. But most of the stuff makes sense. So for example, in the viewport, how do you navigate? Well, you hold middle mouse to pivot. You can zoom in and out by scrolling. You hold shift to do this thing, and it's pretty similar. So in the shader editor, which is 2D, not 3D, we zoom in and out with the mouse wheel. We pan around by holding, middle mouse button, and that's pretty much all there is. There's no 3D rotation for this 2D thing. So zooming in and out and just moving around. Okay, cool. As for the nodes, we can select them by clicking them, do box selection, Alt-A to deselect, same stuff as usual. I'm assuming you've probably used Blender a bit and you're not just hopping into this first time with materials. So we move around, we select. For moving nodes, you have one selected, you hit G for grab, and it works exactly the same. Pretty much every shortcut you already know works here too. To delete something, you hit X, and you can undo it. And again, X over here, it's all the same stuff over and over and over again. And yeah, I think the only other shortcuts we're going to be talking about right now, there are a ton, but for right now, we want to talk about how to quickly disconnect and connect nodes. And normally the way you do this is you just hold this connection and drop it into the background to disconnect, and then you do the opposite to connect, and you can do that to any socket of the node. But since we have Node Wrangler, the fast way to do it is you hold Control and then right-click and drag to cut. So again, Control, click and drag to cut. This works if you have multiple connections. So I'm going to draw a line passing through all three of them. And now that's gone. And then for a fast connection, so instead of doing this, what we're going to do is hold Alt and then do the right arrow or right mouse button drag. And you can see that it's highlighting which nodes are going to be part of that connection. So if we duplicate this, by the way, duplicating is Shift D, or you can just, copy, paste, should be, yeah, there we go. Same commands as always, seriously. If we have two of them, we can hold Alt, right-click and drag, and then choose which one we want to be fast connected. We're going to do this one, then let's do this one, and we hold Control and right-click to sever this, sever that, and that's pretty much what you need to know. So pretty much right-clicking is the thing that lets you do Node Wrangler stuff, and you either hold Control, Alt, and there's also something for Shift. So for Shift, if you hold Shift and then do it, you're going to see we get this line, and when we drop it, it's going to have a hinge. I'm sure there's a good name for it. I think it's called rerouting. So the point of this is, let's just delete it. Instead of having something like this, which can get pretty messy when you have a bigger node network, you hold Shift, right-click, drag, and you have this nice thing that you can reroute everything to. It still has the same information, but whatever. Okay, cool. You now know hotkeys. I hate talking about them, so we are done with them. And by the way, yes, G for grab, but rotation and scaling don't do anything because it doesn't really make sense in this context. Okay, so now some other basic stuff before we switch out this node for other types of nodes. You can think of this as this giant green principled BSDF is basically holding a lot of information about what we want our material to look like, and then we're sending all these instructions through the connection or the noodle to the material output. And more specifically, it's going to the surface socket, meaning take everything here and send it to the surface, the material surface of any object that has that material. Pretty simple. So it doesn't really matter where this is. This is the same node network as this one. It's really topologically equivalent, or there's a name for that. There's like, this doesn't matter. Doesn't matter. I was going to do some mathy nerd stuff. So what I'm saying is if we have two of these, one's red and one is blue, no matter what we do to this, it's not going to matter until we make this what is connected, and vice versa for this. Doesn't matter. And again, Control, right-click to sever, Alt, right-click to connect. And if you can't remember that because your brain, I don't know, can't handle that much information, you just do it like this. And yeah, there are many more hotkeys, but let's ignore those. So instead of messing with this principled BSDF, that can get pretty confusing. You have color, you have how metallic it is. I mean, you can just kind of drag these things and see what they do. Here's roughness, it's like how much does it look like a mirror. Instead of doing all that, what we're going to do is we're going to simplify. So instead of that giant thing, we are going to add a node called the value node, which is the kind of the atom. It's the base, most basic node you can have, and then you build up from there. So to add, you do the same thing as in the viewport. So viewport, you do Shift-A, or you just click Add and then choose what you want to add. Same thing here, Shift-A to add a node, or you just go to Add and select your node. So we're going to do Shift-A and then either go to Input and then pick Value, which is going to add that. You can do that, or you can do Shift-A and then type it in right here, Value. And I think you can just hit Control-A. No, that's a function nodes thing. Shift-A, type in Value. And this is how I like to add all my nodes, because once you know the names, you kind of don't want to go through the menus. So again, we take this, we connect it either that way or Alt right click. And now you can see that it went from black to, you know, gray or white or something. And this node isn't as scary as what we had before, which was this giant thing called, again, you can just type it in, principled BSDF. I mean, compare these two nodes, if you know what I mean. Okay, so we have a value node which has a value. Right now that value is 0.5, and we can change it. And by the way, when you hover over something, it tells you what it does. So default value, input value used for unconnected socket. Sometimes it's going to be more useful than that description, but whatever. What we do is we take this and change it, and you can see our cube is going from black to white, etc. And if we look more closely, notice that as we go down towards 0, it gets darker. And then once we get to 0, let me just type it in, it's a pure black. And if we go to negative, so even lower than that, it stays black. Conversely, if we go up from 0 towards 1, it turns more and more white. And then because of a technicality, which we'll talk about in a second, you can even make this bigger, and you can kind of tell it's getting even brighter. So 1 compared to 10, 10's brighter. But normally, we use the value node for numbers between 0 and 1. Of course, this isn't always true. I mean, we have so much freedom. We can put whatever we want. We can even type in something like pi, and it's going to give us, you know, an approximation 3.142. And if you click this, it will give us like 6 digits or something. You can put in whatever number you want, fractions, negatives, whatever, giant numbers. But there is a reason that we'll talk about that we go between 0 and 1, which makes me think, okay, well, if 0 is black and everything under 0 is still black, and 1 is white, why does it get brighter than it is currently when you go above 1, right? If I'm saying it goes from 0 to 1, why is this showing something different? And, you know, there's a lot of reasons for what I'm about to explain, but really this is just a color management thing. So if we go to the Render tab and we go to Color Management, so Render tab, Color Management, in View Transform, it should by default be set to filmic for you, I think. We're going to take this and switch it to standard. And basically what this view transform is, it kind of tells Blender how to handle colors. So standard kind of works the way you expect it to. So 1 is white, and if we make it brighter, nothing happens. Nothing's happening, meaning 1 is the cutoff and 0 is the cutoff for black. Meaning that you can still do something below 0 and something above 1, but it doesn't really matter in this sense of seeing the color on the surface of our object. Something like Filmic has more high dynamic range or whatever, and that lets you go even higher than 1. So maybe you can think of it as a, I don't want to say 1 over x, but I'm saying that you can keep getting brighter and brighter and brighter, and as your numbers get huge, you know, how much brighter it gets kind of slows down, but you can always keep going. So it goes from like 0 to infinity instead of 0 to 1. I'm just saying keep it on standard and don't worry about it. So there you go. So we have this on standard. We go to 0, it's black. Negative is, you know, still black, anything under 0. And then we go all the way up to 1, and then nothing happens. Okay, cool. So now we know the value node, and this is a great way to make an object either black or white, and you're thinking, okay, I don't know what this has to do with anything, but it's a good fundamental thing to understand because we build everything up from this. So hopefully you understand the value node. We can have 2 value nodes, one's 0, one's 0.5. That's a comma, 0.5. If we take this and connect it, what's going to happen? Think about it. It turns gray, so somewhere between black and white, halfway in between. If we change this one to 1 and we connect it, what's going to happen? Think about it. It's going to become as white as possible, assuming we're in the standard view transform. Okay, cool. What about negative numbers? We said that it's black, so how do we even know that it's actually storing this number? What if it's actually just, if it's a negative, it just says that it's 0 and makes it black, right? Is there a difference between -1 and 0? So here's -1, here's 0. Is there actually a difference? And I would say there is, and I'm going to prove it to you. So we're going to have two -1s, and now I'm going to teach you about another node. So you can go Shift-A to add, and then I'm trying to think where it is. Is it in Converter? I'm looking for the Math node. So in Converter, you're going to find Math, or, of course, Shift-A, type in Math node. Okay, cool. So now we have something a bit more complex. It looks a bit bigger than the value node, not as big as the principled BSDF. Okay, so if you go to this Math node and check the dropdown, you can see there's a whole bunch of mathy stuff, which some of it you may recognize, some of it you don't, but I can guarantee you recognize division, multiplication, subtraction, addition, and that's what we use for most of our mathematical operations. So, I mean, if you're scared by this, get out of here, okay? It's just addition, subtraction, multiplication, division. You can handle it, I swear. So what we're going to do is I'm going to set this to multiply. And you can see it has two values. We can connect this. Let's connect this to our surface. And notice that right now we have 0.5 times 0.5, which is 0.25, which is, it's closer to black than it is to white because it's, closer to 0 than it is to 1. If we do 0.5 times 2, which is 1, you can see this turns white. So if I make this value node 1, so these two things are essentially equivalent. Here we have 1, here we have 2 times a half, which is 1. If we switch these, nothing really happens. It looks exactly the same. Okay, cool. So you can either just, put in numbers here and here and have it do an operation, or you can instead plug in numbers instead of just typing them in here, which is good because you can control them from separate nodes. So let's take this and connect it. So we have -1 multiplied by -1, and it gives something that's white, because -1 times -1 is 1, which is as white as you can get. But that proves that -1 isn't like rounded to 0, right? Even though it's black, it still has that information. And hopefully you understand what I mean by this. If these were zeros, this wouldn't work again. So times 0 is going to give us 0, because anything times 0 is 0, and I think you get the point. We can also do other operations like, let's say, addition. So -1 plus a -1 is a -2, which is under 0, so it's black. And if we want this to be exactly white, we would need this to be 2, because 2 plus -1 is 1. If we want this to be exactly 0, we put in 1. 1 plus -1 is 0. And then if we make this anything bigger than 1, it's going to be slightly more closer to white than it is black, right? It's going to become gray, is what I'm saying. And you can see that in action. Okay, there we go. That's pretty simple. I think you understand. Of course, the math node, let me undo that. The math node has tons of operations like, sines, cosines, trigonometry, and then also some other things like greater than or less than. Let's just do one of these. So greater than, we'll check if, it describes it. 1 if A is bigger than B, else 0. Meaning, if something is bigger than another number, it's going to output true, meaning white. Otherwise, it's going to say false, which is 0. So let's try it. Let's see 2 and 1. Is 2 bigger than 1? Yes. Let's try it. 2 greater than 1 outputs white. So it's outputting 1. If instead I made this 0, is 0 bigger than 1? No, outputs black. Now if we make these the same, I'm not sure what it's going to do exactly. I guess it's going to output false because greater than is like strictly greater than. It's not greater than or equal to. If we make this anything bigger than 1, immediately it shifts to white. And I think you can probably understand why. So math node, tons of stuff. And then the last thing I want to leave you with for this introduction is we have value, which is one kind of gray scale. If you think about it, it's either black, gray, white. You can't really get any color out of it. How do we take this and then level up to color? Well, the way I want you to think about this is any color, it can be described by how red, green, and blue it is. So red, just the color red is 100% red and 0% green, 0% blue. And then, and then something like purple is like, half red, half blue. It's like mixing colors. We'll talk about it. So what we're going to do is we're going to do Shift-A, and then is it converter? We want a combine node. Let's see, is it in here? Yes. So in converter, you can see all these combines. I'm going to add a combine RGB, or you can just type it combine RGB and just add that in. And we take this, and you see it has a yellow socket. which normally indicates, color or something that isn't grayscale. So you can see values have this kind of grayness to them, and these three sockets for inputs are also gray, and it outputs something with color. And we'll talk about what green and purple mean and all that, but let's just connect this, which gives us black. We can take this and make it more red, so you can kind of see what's going on there. We can make it more green, make it more blue, or we can mix them. So if we take something that's 1 on red, meaning 100% red, and also make it 100% blue, we got purple, right? It's mixing colors. If we do red and green, I think that's yellow. Yeah, and green, 100% green, 100% blue. What does that give? I guess it gives like teal, turquoise, something like that. So normal mixing colors. And again, we don't need to type it in these sockets. Instead, what we can do is we can have 3 value nodes. Again, that's Shift-D to duplicate. And I'm just going to connect them. And again, use the Alt right-click thing for the shortcut. And you can see that we have something that's perfectly white because it's 100% red, 100% green, 100% blue, meaning that it has all the colors and that's white. And of course, if we change these to 0, we get black. Okay, cool. And you can see that if you pull this slider, it doesn't let you go under 0. Maybe you can type it in. Nope, it just rounds to 0. It doesn't let you go under 0 or above 1. And this is what I'm talking about, where a lot of nodes just want you to use the 0 to 1 interval. Of course, you can type in over here -2, and we talked about how it actually stores that. But yeah, I mean, 0 to 1 is what we're using a lot of the time, so we need to get used to it. So we have combine RGB. Let me just reconnect these. And you can see the nice thing about Node Wrangler is it will automatically detect if a socket is filled up. So if we do this, it's going to automatically go to green, and then to blue, and then whatever. So let's just set all of these to 1, making it perfectly white. And I just want to play with this a bit more so you understand. So here's blue. We can take this down, and if we remove the blue, all we're left with is yellow. Doesn't matter what arrangement we have these in. Again, it's topologically equivalent. It's invariant to change. There's a word for this again. Doesn't matter, but it exists. Yeah, so you can just slide these around, and then you can also do the opposite operation, where if you have a color, so instead of combine RGB, we can just add an RGB node, which is kind of like skipping the middleman of choosing a red, green, and blue. I mean, you can, pick your color wheel and then set RGB values, or just, choose it from this color wheel. Conversely, let's put this, so it's going to be, this shade of green. We can do the opposite. So instead of taking 3 numbers, combining them into what is a 3D vector, don't worry about it right now, and then, showing that as a color, we can take this 3D vector, meaning just a list of 3 numbers, how red, green, and blue it is. We can take that, and instead of a combine RGB, converter, separate. Where is it? Separate RGB, or just type it in. And in the beginning, you're probably not going to memorize these names, but that's fine. And what the separate RGB node does is it takes our RGB, our color that has some amount of red, green, and blue, and then separates it instead of combining it. So I'm just going to choose a color that is, pretty much perfectly green. So you see red, it's outputting black, which means it's 0. Again, black is 0 or negative, but in this case it's 0. Meaning this shade of green has no red in it. If we do green, you should expect this to be somewhat white. Perfect. And then blue, it should be close-ish to 0. Let's see. Yeah. And then if we bring this somewhere over here, that's kind of like a turquoise, we can expect our blue to become, think about it, slightly brighter. Cool. And we can actually put in exact values. So let's have this be 1, 1, and 1, meaning that blue is going to be 1, green is going to be 1, red's going to be 1. We can make this exactly 0.5, and it's only outputting our red, which is 0.5. So if we add a value node of 0.5, this should look exactly the same. There you go. And of course, you can mess with stuff in between. You don't have to immediately connect it to the surface of our material output. We can add in a math node. We can add in a math node, as we talked about. So here we have red value of 0.5 and 0.5, and we can just add these, making them 1, perfectly white. And then we can bring that down. So if I make this 0, it's 0.5. If I do negative 0.5, so again, 0.5 plus negative 0.5 is 0. So yeah, there you go. I mean, we can always like dive into this a bit more. So, there's math for combining values, which is one number, but there's also math for combining colors, which are lists of three numbers, and there's ways to do that. But I think this is a good introduction to the hotkeys, to simple nodes, and to me ending this video very soon. If you enjoyed this, you can like, you can subscribe. These are all things you can do. But if you want to support me in a way that sees results and lets me keep making tutorials, please donate to my Patreon. There's a link in the description, and you also get benefits, but that's not the point. You do it if you want to support me, but it is your choice. That's all I have for you guys. Hey guys, welcome back to another Default Cube CG Matter tutorial, and today we are doing part 4 of the procedural node series, and over the last 3 episodes we've kind of been building up the difficulty. We went from baby to toddler to probably still toddler, but today we are going to full teenager, so I expect to lose some of you today. And yes, you are the weak ones if you drop out, so let's get into it. So today we are going to be doing green screening, and I found this dopey looking image that we're going to be using. Can you guys see that? Yeah, you can see that. And yes, we're going to be doing green screening using a bunch of math, and if you remember from everything we learned, we now know how to use value and how to use color and also a bit of math, and it turns out that's all you need to do green screening. And I think that's a pretty unique way to teach nodes. So like I said, this is a procedural series, meaning that we're not going to be using textures, but just for this one, for the purposes of example, we're going to be using this image as a texture, but these ideas, these fundamental ideas, are transferable. But I thought it'd be funny if we used this businessman. And basically the approach we're going to be taking here is we're going to take this image, we're also going to pick a color, being, this green in the background, and then we're going to calculate the distance between the green we chose and the rest of the image. And, as you might expect, the distance between the green and this background, the green screen, is going to be 0 because they're the same. And then wherever this businessman is, it's going to be some number bigger than 0. So, like, for example, maybe the skin is closer to green than the black of the business suit. And then we're going to say wherever the distance is 0, just get rid of the texture. That's the idea. So that should isolate the green screen, and that's just a bunch of math. And to calculate distance in a 3D, since that's what we're doing, because we're finding the distance between two colors, which has R, G, and B, three-dimensional vectors and all that. We'll talk about it. We need a formula for calculating distance in 3 dimensions. And that formula is going to be this one, which is the Euclidean distance formula. And yeah, it looks intimidating, but really it's just a 3-dimensional version of the Pythagorean theorem. So instead of like x squared plus y squared is equal to z squared, or maybe a squared plus b squared is equal to c squared, I don't know what school you went to. Basically now we're doing the 3-dimensional approach, and the whole idea of this tutorial is just getting used to using math more intimately. So again, version 2.81. I'll point out when we finally upgrade to 2.82. Let's switch back. There we go. Let's go full screen. And then for this one, first time ever, we're not going to be using the cube, but instead we're going to be using a plane because we just want to see our green screen texture. So we have this. We go to the shading workspace like always, and we have Node Wrangler enabled. I don't want to tell you again. And since this doesn't come with a default material, because the cube does, it should be in our dropdown, so let's check. And it is, so we're just going to assign a material. So now this object, which has one face, has the assignment of this material, and again, we can choose the color. So truly, this node network is the material affecting the object. We'll stop talking about that maybe 5 tutorials from now. So we can call this the green screen material, since that's what it's going to be. And then we're just going to select this, and then X to delete. We already talked about this, same hotkeys. And we're going to start off by actually importing in our image texture, and that's something we're not going to be doing very frequently, again, procedural. To do this, either Shift-A to add, or just go to add, and we're going to type in image texture node. You can also do Shift-A, input, and then is it in here or might be somewhere else? It might be in texture, and then image texture, so same thing. And what we're going to do is connect this to the surface. Again, Alt, right-click, drag is the fastest way to do that. And then open up the texture of, I just downloaded this from Google Images. You can pick anything. And yeah, so again, this node, which we haven't talked about and probably won't talk about again, just stores an image texture that we loaded from the hard drive and sends it to the surface of the material output. And you can see it's kind of looking stretched horizontally, like compressed. And there are ways to deal with that without changing our plane. But since we haven't talked about texture coordinates, we're just going to scale our plane on the x-axis to correct for that. but there is a way to do that without changing the shape of it. Okay, cool. So how are we going to do this? Well, again, what we said is we need this image, a color being this shade of green, and we need to calculate the distance between them, between the green and the texture using Euclidean distance and all that. Let's take it step by step. So since we need access to the whole three-dimensional stuff and all the math, we don't want the color, again, yellow socket means color, of the image texture. We want to control the individual values of red, green, and blue. And like we talked about, we can use combine RGB and separate RGB. So Shift A, this time we're just going to type it in, and add a separate RGB node, which again shows us only the red of the image, only the green, only the blue, and as you might expect, for red and for blue, the background is going to be completely black because it's a value of 0 of red and blue, but it's 1, or should be around 1, for green. And by the way, I haven't talked about this hotkey. You're probably wondering. Instead of doing my like alt right click or maybe just selecting one and dragging it, another hotkey that I'll now introduce is you hold Control, Shift, and then click your node, and that's going to hook it up to this like temporary viewer node. But what it really does is it just has it display really quickly. So Control Shift click on this one. Now we're viewing this, and then here, and if we keep clicking it, it's going to cycle down. So that's Control Shift click. That's a useful one. I use it quite a bit. Okay, so now we have access to red, green, and blue of the image, and we're also going to add a color. Again, we can do that from combine RGB, which lets us control the amount of red. So this is completely red. If we add some green, it's going to turn yellow because we're mixing these, etc. So we can either do that and then try to, guess what shade of green it is, or instead we're just going to add an RGB node, which I think we talked about. And now we're viewing that one. And we need to pick the shade of green, so you can kind of like approximate it based off our texture. But instead, what we're going to be doing is actually using a handy feature, which is you open up your color wheel, and then with this eyedropper tool, you just select the exact shade of green. So we can, I wonder if it works for the whole screen. Like, could I select this shade of gray? Looks like I can. So that's really the trick we're going to be using here. So instead, let me just undo. And that should be the same shade of green. Let me just make sure. And yeah, so now we're using the same shade of green, and we can send this through another Shift D to duplicate, or just, again, Control C, Control V. Eventually, we'll stop talking about hotkeys. We're going to send this through a separate RGB node, which again lets us see red, green, and blue. And it's going to be most green, which is going to be closest to white. And by the way, I didn't even mention, as always, since we want to be working on intervals between 0 and 1, in this case it doesn't matter because we're doing it all mathematically, but visually we want to be using the standard view transform. And we talked about this. Instead of having a whiteness that can just keep going past 1 all the way to infinity, we want 1 to be as white as you can go and 0 to be as black. So negative numbers are black, numbers above 1 are perfectly white. Okay, cool. Now the only other thing I want to make sure that you do is with this RGB node, you open it up and you're going to see it's going to be selected to hue saturation value. That's what this stands for. Make sure it's on RGB. Basically, these are two ways to choose a color. RGB is a color, is how much is it red, how much is it green, how much is it blue. Hue saturation value is just what hue, like what type of color it is. So I'm going to change hue. You can see it goes around the color wheel. That's what that means. Saturation means how intense it is. So if we drag it, you can see it's going towards the center. And value is how bright it is. So you can see we're changing the brightness. So really this is kind of like polar coordinates versus rectangular coordinates, whatever. Just choose RGB and make sure to select, let's view our texture and make sure to select that. Okay, perfect. So make sure that's RGB. Okay, so now we have two three-dimensional vectors. In other words, we have two colors. One of them is a bunch of colors, being this texture, and the other one is just one color, and we've separated them into their components. Now we just need to do the basic formula, and again, if you don't know the Pythagorean theorem, basically what we're going to do is we're going to compare the reds by subtracting them. So we'll do this red minus this red, and then same thing for the green, this green minus this green, this blue minus this blue. Whoops. So basically we pair them together, then we square them, add them, and take a square root. So it's kind of like a squared plus b squared. And the square root comes from the c squared. Don't worry about it. Don't worry about it. This is just practicing some math. read up on the Euclidean formula if you have no idea what I'm talking about. I said this is going to be adolescent level. We're upping it. This is high school math now. So we are going to be adding in a math node to do our math. And first of all, we want to compare reds. So we are going to set this to subtract. And you can either click that or you can just type in the letter S. And for like division, you type in D greater than G, basically the first letter. So we're going to do subtract, we're going to do red, alt, right-click, drag, and then same for this one. So now we are comparing the amount of red. So there you go. You can see that the background is black because this color is perfectly green, so it's not going to have any red, and this texture also doesn't have any red here, so when you subtract them, it's going to be 0. Now we can just take this, duplicate it, and now do the same thing for green. And by the way, let me talk about another shortcut that might help, because if we alt, right-click, drag, it's still going to use our red, because that's the first up. A way to avoid that, I think, is you hold alt, shift, and then do it. So now we get a blue line, and now we can actually select where it comes from. So instead of going from red, we're going to start with green and send it to the first value. So it goes from green to the, did I say second? I meant first value over here. So again, alt, shift, right-click, drag, from green to the second value. Okay, cool. Now let's just pair up our blues. And really, you can do this more efficiently with actually only 1 or 2 nodes, but I just want to talk about separating colors into their elements. So from 3D vectors to their red, green, and blue, do the math, and then combine them again later. It's not the best approach, but it's fine. So we are going to combine the blues now. And this one I'll just connect manually. So here we go. Red, green, blue, cool. Nice. So now what we need to do is we've subtracted, now we need to square. And you can either do that by setting this to multiply and just multiplying it with itself, which is the same thing as squaring, or instead you can use power, which is like exponent, and you set the exponent to 2. So we take what we plug in here and raise it to the power of 2. Take that, duplicate it, and do the same thing over here. So once you make kind of the stuff for the red, you can just duplicate everything down and it will be pretty fast. And again, we can view all these, Control-Shift-Click, click, click. Okay, cool. So now we've done all the differences squared. Now we just add these things together. So duplicate another math node, set this one to add by just clicking A. We're going to add these, and sadly there's no way to add 3 things using one node as far as I'm aware. So we're going to add these, and then we're going to add that to this sum. So instead of adding it in 1 step, we have to do it in 2. And you can already see what we get over here is essentially a matte of basically where there isn't green, or where there is green to where there isn't green. And you can see that it's not perfectly white, like this area is a bit gray, meaning that the original image, this shade of like purple or whatever, must be slightly closer to black than everything around it. So technically, this is a fine measure for measuring the distance between our green and our texture, but technically it is correct. It is correct to take a square root at the end, which is a monotonic function, so it doesn't matter. But there you go. So now we've basically made a node network that takes 2 things and then calculates the distance between them in terms of color. So again, the way you want to think about this is that where it's white, you have maximum distance between the colors, meaning that they're very different. They're kind of like on opposite ends of the color wheel, very far apart. And then where it's black, the distance is very close to 0, meaning that they're almost overlapping and are almost the same. Okay, cool. So now how do we take this matte and, use it on our texture? So we want our texture, but also, remove all the green so we can put something in the background. And there are a bunch of ways to do that, but I think probably the coolest is to introduce, if I haven't already, the mix RGB node, which is kind of like the math node, these math nodes, but for colors. So not just 2 values, but 2 colors. It doesn't work with gray sockets, but rather with yellow sockets is the way you want to think about it. So we can either Shift A, and then I think it should be in Converter. I'm not sure exactly where it is. We're looking for Mix RGB. Maybe it's in color. Yeah, Mix RGB. Or again, you can just type it in. Okay, cool. And it looks pretty similar to the math node. You have like 2 inputs, a kind of mode you choose, like addition, subtraction, whatever. Then it has some extra stuff. It also has this clamping, which we can talk about later. But yeah, it's pretty similar. So what we are going to do is for our mix node, we are going to, and this is where Node Wrangler becomes very useful because trying to select this and then do it from very far away is hard. We're going to Alt, right-click, drag, and now this texture is in the first socket of our mix RGB node, and then we're going to take this one, same thing. Okay, cool, and view it with Control-Shift-Click. And basically what it's doing right now is it's taking our two inputs, being the texture and the color, and doing something called mixing. And there are a bunch of different things you can do. You can either mix, you can color burn, whatever. Each of them have different meanings. And then we can also control which side this operation favors. So we can pick a factor of something that just favors. We'll talk about what that means. Our color, or we can have it favor our original texture. And I'm pretty sure what mixing technically means is it's averaging out the two colors, so it's splitting it up into components, averaging them on red, green, and blue, and then combining them. But there's also different kinds of operations. But you can see that when we change this factor, we can have it, kind of reveal one or the other. So what we want to do is have it reveal our texture only where this is white, and then reveal our background wherever it's, black. So what we do is we just take our factor, and instead of picking a number, we input this, it's a value, meaning it's between 0 and 1, and it's one-dimensional, but really it's kind of like a texture of its own, because it's different at different points. It's not white everywhere, which is something we haven't done before, I don't think, where it's different in different areas of our geometry. So let's take this, make it our factor, and view it. And you can see that we're getting something very confusing. So first of all, to clarify, what I'm going to do is I'm going to take our green and I'm going to disconnect it. And you can see now we have something that's pretty close. We have our green, and then we can actually choose the color. So it's kind of like we have an inverted green screen. And as you can see, like we talked about, hopefully YouTube compression doesn't kill it, you can see a bit of difference over here where the color was originally closer to green. And the way you want to think about these nodes that have two inputs, especially not necessarily in the math node, but in general, you want to think of bottom as foreground. It's this really horrible design that Blender has. So instead of layers where the top one's the foreground, the bottom one's the foreground. So we have our image texture, and then in the foreground, we have this shade of purple, but only where this factor allows, which is, where this was white originally. So what we can do is we can just take this and put it in the foreground. And now you can see wherever the factor is white, we have our image texture, which is on the bottom, which means the foreground appearing. And then we can actually choose our background color. And this is exactly what green screening is. We've removed the background and then we've chosen a different color. Now, of course, there are two things to address. First of all, can we put like an image behind here? And second of all, what about this green outline? So first of all, let's talk about the texture in the background. Well, first of all, let me ask you, where would you plug it in? Think about it. Well, it'd be exactly wherever this magenta is, which is the first socket, which is the background. So again, Shift-A, image texture. Again, we're going to try to not use these in the future. Open, desktop, and let's go with the thumbnail from the last one. I have these really strange thumbnails. So let's take this and plug it into the background. And that is a green screen. Now, the question is, how do we get rid of, this green outline? Meaning, our factor is a bit messed up at the edges. And as you can hopefully see, this thing is mainly black, mainly white, but on the edges it's very, very slightly gray, meaning that the distance isn't super far away on the edges, but just kind of halfway in between, and that kind of makes sense because you have the green screen probably spilling light onto his sleeves or whatever. So it's a bit green, so it's actually a bit closer than everywhere else. So the way we deal with this is we want to say only keep everything that is very, very far away. So instead of just looking at the distance and then being like, show this wherever the distance is high and where the distance is low, don't show it, and in between kind of half show it. What we want is a cutoff. And to do that, there's a bunch of ways. We're going to take this. First of all, it's kind of clean up over here. Going to bring this down. So what we want to do is we want to take, again, all these nodes we did, all these blue nodes are calculating the distance. And now we just want to do a bit of a cutoff. So I'm going to duplicate this and add it over here. So now this is what's going into the factor. And we are going, let me actually view it as well. and we are going to set this to greater than, which again, it outputs white if it's going to output white if this, whatever we put in here, is greater than what is over here. And clearly the whole image is black because nothing is going to be greater than 2 because our factor is going to go between 0 and 1. The distance goes between 0 and 1. So if we set this to 1, we have only the parts of the texture that are very, very, very not green, which I guess is probably apparently where his skin tone is. So maybe his skin's very orange, which is very opposite from a green. Maybe not, it looks pretty close on the color wheel, whatever. So what we can do is now we have kind of like a threshold, and we can just bring this down and reveal different amounts of our image. If we bring this too low, like to, 0, everything is going to be white because even if it's a distance of 0, or maybe 0.001, it's going to be bigger than 0. So the green screen is effectively not being used. So we need to just choose a factor that has a nice effect with our edges. So I don't know. Let's try 0.3 and we can view it. And you can see we still have our edge, so we just want to slide around this value and you can see it's kind of going away. But of course the issue is if you make it too intense, it's also going to cut out, parts of the interior, like, these fingers and all that. So you kind of want to pick the optimal value that doesn't have that effect. And of course you can do a bit of math to actually do what we want to do, but also keep the interior. But we're not going to get too complicated on this. This is just like a tutorial to do a bit of math. But you can see that this is a better result than not having it. So this is not having it, and this is having it. And by the way, what I'm doing is I'm clicking M, which is another hotkey, to mute. And basically what it does is it kind of goes through the node network, but almost assumes that it's not there. So you kind of want to imagine this wire just passes through it. So M to mute and unmute. And yeah, the cool thing about this setup is once you make it, you can use it on a bunch of different scenes. So if we just look up more green screen stuff, let's just find a different one. It could even be a different shade of green. Looking for something that looks a bit different. Okay, this one's probably not going to be the best, but we can try it. Because there's 2 different shades of green, and our green screen setup is very, very not intelligent. We can make it better, but right now this is what we got. We can make it kind of like have different kinds of sensitivity depending on different situations, but don't worry about that. So what we're going to do is we're going to set our image, this is our businessman, and change it over to green screen number 2. And then let's also view it. What we want to do is also change our green. This is the color we're comparing everything to. And we want to pick the updated style of green, so something like that. And then let's view it. That's not looking too hot, probably because of our greater than value. So first of all, if we set this to 0, nothing happens because of the reasons we talked about. But if we gradually, you've probably seen this if you've done green screening in any kind of program, kind of does this kind of thing where it has this kind of rough edge. And this means the green screen probably wasn't very evenly lit. There might have been more shadow over here. But we're just trying to remove pretty much all the green, which is everything except the head. And that did a pretty good job. Of course, like I said, our node is garbage. You can kind of optimize it by adding a bit more math. So something people like to do is add a power node. So right now we're doing a power of 1. So anything to the power of 1 is itself, so it doesn't change anything. But we can kind of change the fall off using this technique as well. But yeah, I guess that is green screening. I think I taught it to you. And I think I didn't even go too much higher up in difficulty than the stuff we were talking about before. Again, colors, math, all that stuff. Make sure to refresh yourself on Euclidean distance. Because if you don't know where that formula came from, it might seem like magic. Basically what I did is this is the Euclidean distance between 2 points. So imagine you have 1 point here, another point here. Whoops, is it now only showing? Imagine you have 2 points. 1 here, 1 here, and you need to find the distance d between them. You compare the x, so that's x minus x like we did, so that's the red minus the red. You have the green minus the green, and then you do some squaring and the whole Pythagorean theorem nonsense, but instead you're doing it in 3 dimensions. So there you go. I'm sure I lost about 90% of you, but don't worry, they're the weaklings, and the rest of you can keep going forwards. In the next one, I think we're just going to kind of go off topic a bit and just talk about drivers, and then eventually kind of the goal is to get to texture coordinates because that's where all the interesting stuff happens. So yeah, there you go. If you appreciate these tutorials, what I mean is if you want to donate to me, the way you do that is via Patreon. It is the best way to make sure I am funded to keep making tutorials and have the time and I'm willing to put in the effort, although I love making these. It does help if it actually is kind of a job, and I try to make the best tutorials out there. So hopefully you like this procedural note series. Patreon would be greatly appreciated, but that's up to you. And other than that, I guess that's everything I have for you. Bye. Hey guys, welcome back to another Default Cube CG Matter tutorial, and today we are doing part 5 of the procedural node series, and the topic for this tutorial is going to be drivers. And if you've never heard of drivers, that is a good thing because you're about to learn about it. So it's kind of hard to describe without showing you, so let me just do that. And I should preface this tutorial by saying that I just recorded a CG Matter tutorial, so my voice is gone and it might crack every once in a while, so that's going to be embarrassing for me. So, first of all, what are drivers and what am I going to be teaching you? So remember from the last 4 parts, assuming that you've seen those, we have a combined RGB node, which is basically saying, let me just add another that we haven't altered yet. A combined RGB node is just a way to choose a color by picking a red, green, and blue amount, so I can make it more red. As we approach 1, it becomes fully red, and we can mix it with something that's fully green, so red and green make yellow, and then if we also add 1 for the blue, which means maximum amount, we are going to get white, because we have maximum amounts of red, green, and blue, and then conversely, if these are all 0, we get black. So we already know what combined RGB is, but you can see that my version, which I'm going to connect, my version is purple. And you may be thinking, okay, what's up with that? Well, what does that do? Well, what these sliders are actually rigged to do right now is notice what happens when I take my cube and move it. Oh, so moving it is actually altering what these values are. And you can see once I finish a movement, so I'm just going to click here, you can see I moved it along the x-axis, and this has updated for red to 2.665. And if you're thinking, oh, did I take this x value and copy it here dynamically? Then yes, that is exactly what I did, and that is exactly what a driver is. So we have a pretty simple setup. We can either control it by moving these location sliders, which again are the same as these sliders, or we can just move it in the viewport. So if we want something that's perfectly red and green, meaning yellow, we just set this to 1, set this to 1, and you can see these don't really update that quickly. It's kind of strange, but usually you just have to toggle a frame and it happens. You can see that it's actually updated. And again, this works dynamically, and that is the point of drivers. And the z-axis I reserve for making it blue. But again, it only goes between 0 and 1, so once you go past an x value of 1, it just remains red. Okay, so this is what a driver is. I think you understand the demo, so let me just go full screen and start up a new scene. And then I guess there wasn't really too much point to that because we just need to go to the shading workspace. You know what that's all about. It's where you edit your material. So again, probably the last time I'm going to say it for this tutorial, and I'm not going to say it in future ones, hopefully. We have a cube that is some geometry, which has this material assigned to it with the name material, and that material is basically made up of this node network. With this node network, I'm going to replace this principled BSDF with Shift-A to add, and then I'm just going to type in, you can either do an RGB node technically, but what I would recommend is combine RGB, because then we can actually manipulate these sliders individually. And then additionally, like we talked about, we can add in a value, which is a single number, to control this instead if we just want to separate it for some reason. So to do this driver stuff, it used to be pretty hard, but now that we're using 2.81 and onwards, it's actually gone a lot easier. What we have to do is I'm going to hit N to reveal this location, rotation, scale stuff, or you can go to the object data, I think. No, it's one of these. Object properties, yeah. Here you have location, rotation, scale. What we're going to do is we're going to right-click any value that we want. So let's say we want the X location. You right-click, and then you click Copy as New Driver. So we are going to be copying this X value, whatever it is, no matter what we update it to, as our driver. And then let's say we want this affecting our red channel. We right-click and then do Paste. There we go, Paste Driver. And now when we change this X value, you can see after we toggle the frame, it's actually going to update here, and you can tell that it's being affected by driver because it's purple. And of course, you can do this dynamically, and you should be able to animate this and have it update per frame. So if on frame 1 we want it to be 0, We can add a keyframe here. Frame 40, we'll have it go to like 3. Again, it doesn't matter once it goes past 1. I mean, I guess it does matter a little bit since we're not on standard. Again, standard actually has an accurate 0 to 1 where anything beyond 1 remains white, whereas Filmic has this 0 to infinity thing. You can watch a video about that I made if you care. And you can see that it's actually dynamically doing it per frame. And of course, we can do the same thing with other stuff. So for example, we can actually take the same driver, and it's still in the copy. We can still paste the same driver over and over. We can right-click on green, we're going to paste it, and then we're also going to do it for blue. And I want you to think about what's going to happen before I play this animation. One value, being the X location, is controlling this red, green, and blue. So what do you expect to happen? We play this. It remains perfectly grayscale, so it goes from black to gray to white, and that's because at all points, at every frame, these 3 sliders are going to have the same value, so you have the same amount of mixing. So that should be pretty intuitive, and I just want to really stress the point that you could do this for anything. So let's say we take the Y location, copy as new driver, set this to paste. So now, let me actually remove the animation here, so we're no longer messing with that. So now, X-axis controls the amount of red. Whoops. Let me remove this driver. By the way, if you want to delete a driver because blue is still being affected, bunch of ways to do it. The easiest way is to right-click and then delete driver. You can either do that or go into the driver editor, which is one of these somewhere in here. There should be drivers. Yeah, here, drivers. But now we should be able to move to the X-axis to affect red and move along the Y-axis to affect green. And these things, of course, mix because of this combined RGB. We can do the same thing by just putting it in a value thing that goes to green. It's an equivalent setup, although there is reason to do that because you can take this and plug it into multiple different nodes, so you only have to have one driver. So let me just paste it. Oop, Blender crashed. I would normally cut this part of the tutorial, but that is the reality. So that is some kind of bug or something. I don't know. Maybe it's because I plugged a driver into something that has the same driver. That's an issue, but it's in the tutorial. And let me just reset up quickly, combine RGB. So I guess that's a warning to be careful with some kind of contradictions with drivers, or I don't know. But we can take the same kind of lessons and apply them to everything we talked about before with nodes. So for example, instead of just doing something simple, like we just affect the amount of red, we're going to send it through some math first. So let's add a math node. And I'm going to connect this to red. So again, right now it's outputting 1 for a red, which makes it perfectly red because we have 0.5 plus, addition 0.5. So instead what I'm going to do is I'm going to do division. I'm going to set this to 1, and then for the second value, what I really wanted to stress is that you don't, again, need to pick X, Y, or Z location. You can pick scale, you can pick dimension, and in fact, anything that has a slider like this or that we can put an input for, you should be able to actually copy as a driver. So we can actually take the strength of the world. I mean, it's kind of like unrelated, but you could use that as a driver. So in this case, what I want to do is take the frame number. So this controls what frame we're on. And I'm going to right-click, copy as new driver, and I'm going to paste it into the second socket. So we have 1 divided by the frame number, so the reciprocal, which means as we go frame by frame, it's going to become kind of dimmer in terms of red. So here we have 1 divided by 1, which is 1 redness, then 0.5 redness, then a third, a fourth, and as we tend towards, a bigger number, it's going to get closer to 0. And I think, let's see what happens when we play this. Yeah, you see that it's not updating on every frame, so usually it's better to just, go frame by frame, but when you render, since it renders on a frame by frame level, it should work. So sometimes viewport playback doesn't make too much sense. And I don't know if that's a bug, but this video is all about bug reporting for Blender. There are some issues, unless this is a design feature or something. Okay, so what else do we want to talk about? We can pretty much put this anywhere. I guess the last thing I want to talk about is instead of doing it the way we've been doing it, which again is kind of new to 2.81, I think. I don't think it was in 2.8. We can do it the old-fashioned way, which in some ways gives us more control if we don't want to mess with math nodes. So let's say we wanted to take the reciprocal, but not send it through the math node where we did the division. How would we do that? Well, let's say we want the scale, the X scale, to be our driver. We're going to copy this and paste it into red. So paste driver, and right now that means that if the scale is 1 on the X-axis, which it is, we're going to have 1 for red, and then as we scale down, On the x-axis, it gets closer to 0, which means it becomes dimmer in terms of red. If we want the reciprocal, we can either do what we did with the division, or we're just going to right-click, and then we're going to edit the driver. And this is where it gets a bit confusing if you don't know what you're doing. Basically, what you're looking at right here is what is happening behind the scenes. So what we are looking at is this driver is looking at the scale of our cube, and this 0, instead of having it 1 or 2, basically means is it looking at x, y, or z, where I think 0 is x, 1 is y, and 2 is z. That's just some array stuff. Don't worry about it. But what we can do is instead of average value, we're going to set this to scripted expression. And instead of taking the scale, we're going to do 1 divided by scale. So the same way you would write it in a program or in a calculator or something, I don't know. So 1 divided by the scale, then you update. And then, right now it's still the same because 1 divided by 1 is 1. But now when we scale down, you can see it's getting brighter because it's filmic. So normally we wouldn't see that. But what I want to show you is that when we scale it up, it's going to get dimmer because now it's a reciprocal relationship. Before, it would have just stayed equally red if we were on the standard view transform. So that's the reciprocal. We can also do other kinds of math. So edit driver, we could do 1 minus the scale. So right now it's going to be perfectly black because the x scale is 1. So 1 minus 1 is 0. But then if we make it smaller, it should get more red. Yep. And you could, do any kind of expression there. And on top of that, let me delete it. If you're using a different version of Blender, if you want to call different, different data paths that for some reason you can't like right-click or whatever, you can, again, right-click whatever you want to affect. We're going to add a driver now. So instead of pasting one, we're making one from scratch. And then let's say that we want, instead of like the cube, we're going to look at the light. So that's the this light right here. So we're looking at the light, edit driver. So we have the light selected, and we can say, oh, do we want it to reference, where we're moving the light, how big it is, whatever. And I'm just going to choose like X location is fine. You could do a whole bunch of different stuff, but this is a good way to do it. In world space, meaning like what location does it have in the world instead of like local space or whatever. And that is going to be our variable. And then what's being outputted is the variable plus 0. So the way you want to think about it is we're looking at our light, we're looking at the X location, this is our variable, and we're outputting the variable plus 0, which is, the variable. Okay, so let's actually see if this works. So we have our light, I'm going to 0 it out. And you can see this actually made our cube black. And as we move our light on the x-axis, you can see it gets more red and then closer to 0. And basically that means you can kind of texture or have a material of one object reference the location of another. So you could do a lot of cool stuff with that once you do kind of more complicated math. Alternatively, what you can do, let me delete the driver. Alternatively, we can add a driver, and then instead of, picking an object, we can just put in a arbitrary data path and do a lot of different stuff with this. So let's do single property. We can look at, I don't know. I don't really know what I want to pick. So what I'm trying to say here is you can access any part of Blender to use as your driver. So for example, you can see we can pull like stuff from fonts, we can pull stuff from lights, we can, so you can kind of have like the curvature of a spline affect the how red it is, whatever. But yeah, this is just a simple example, and now you should be able to use drivers. And this goes beyond just the, shader editor. You can create a driver for the strength here. So let me just add a, you know what, let's copy this. We are going to copy as a new driver and then paste this into here. And then let me go to rendered view. What this does is as we move our cube on the x-axis, our world should be getting brighter and then darker. So it works on all parts of Blender, but I wanted to show it on the shader editor. So I know this is kind of a departure from all the procedural stuff, but you can see how it might be useful. So maybe you want a material that changes color depending on how close an object is to another. And if you wanted to do that, you could either do all the math about, Euclidean distance like we talked about last time, or there's actually a distance option, I think. Yeah, distance. And then you pick whatever two objects you want. But we're not going to do that here. You can probably figure out how to do that. So yeah, there you go. Another successful, another successful procedural nodes tutorial. Hopefully you enjoyed this one. If you did, the best way, the only way to support me is via Patreon. If you become a patron, it supports me, obviously, but then you also get benefits that are mostly CG Matter related. but you do get some benefits even if you just want to donate. So thank you for checking that out. You know, likes and subscriptions just not as valuable to me to keep making tutorials, but whatever. Thank you guys for watching and enjoying. I'm gonna make more tutorials in the future, and that's it. That's the show. See ya. Hey guys, welcome back to another Default Cube CG Matter tutorial, and today we are on part 6 of the procedural node series, which is 2 parts away from what I would consider as level 2, where we actually make stuff difficult using texture coordinates. So make it through this tutorial, make it through the next one, and then you're going to get onto some harder stuff with some cool results. And today, I just want to talk about kind of what addition, subtraction, multiplication, whatever, what these things mean in terms of regions, which kind of sounds like nonsense until I explain what I mean. But it's going to be very simple, and this is what I expect to be a very fast tutorial, although I said that last time and it ended up being 15 minutes. So, again, we have a plane. I said I won't say it again, but we'll do it. We have an object that is a plane. It has a material. I called it add multiply, and that material is the node network that I'm looking at over here. The reason this looks black is because nothing is connected to the surface of the material output, but you should know this by now. And you can see that I made 2 nodes over here. Don't worry about how I made them. I mean, this is how I made them if you actually dive into this. This is called a node group. I just grouped a bunch of nodes and just compacted them into one unit so you wouldn't have to see everything. Eventually, I'm going to teach you how to make these, but what these node groups do is I'm going to connect this to the surface. Again, you can either do that manually or Alt right-click drag or Control-Shift-Click. These are all ways to do it. And you can see what this does is it gives us a circle that is a bit off-center. Again, the center is where this 3D cursor is, and it's just a bit to the left. And what we want to think of this as is where there is a circle, where it's white, we have a value of 1, it's perfectly white, and then everywhere else is black, 0. So 1 in the interior of the region, and then 0 on the exterior. And then if we switch over to this one, we have kind of the same thing, but it's just over to the right. So now here we have 1, and over here we have 0. Okay, cool. So what can we do with both of these together? So one's a bit to the left, one's a bit to the right. You can imagine that we can kind of make a Venn diagram out of this. So let me just add a math node, and this is kind of the focus of this video. Right now it's going to be set to add, and we're just going to be adding these 2 inputs, which kind of gives us this Venn diagram looking thing, and let's think about why this makes sense. So in this region over here, being like the circle on the left, it looks, you know, a normal amount of white, the same as if we were to just have this node only. So what's happening here is we have 1 from the circle on this node plus 0. If we look at this one, this region is black on this one, and it's white over here. And then together they add to 1. So what I'm trying to say is when we add things, in the past we've just been adding like 2 different numbers, as in 2 different values. So let me just make 2 values and just plug those in here and here. We've been adding just 2 numbers, and then we know, you know, how this works. If we make this negative 0.5, we're going to get 0, negative 0.5 plus 0.5 is 0. And we can do all kinds of stuff, but you see that it's the same shade of gray, white, or black everywhere. And we say that means that it's kind of uniform because we're just adding 2 numbers. It gives an output, and then it shows it. Same thing for multiplication or subtraction or whatever. But again, if we add something that doesn't look the same everywhere, like these circles, we actually get something more interesting. So the math node doesn't just add things in general, it adds per point. So it will add the 2 values at this point, and at this point, and at this point, and it may give different results in different areas, which should be obvious if you're seeing this. So again, this is going to be 1, this is going to be 1, and then where they intersect, where the Venn diagram, the area in common, that is going to have a value of 2, and you can tell because it's a bit brighter. And again, if you remember, if you've actually been watching this whole series, the reason why, even though it's above 1, since normally you do things between 0 and 1, the reason it's even brighter than the 1, which is normally not what we're used to, is because the color management, our view transform is set to filmic instead of standard, where standard caps off at 1 and then everything beyond it is white, and then filmic goes from 0 to infinity, where the higher you go, the brighter it gets. But just for this video, normally we use standard just for this course, but for this video I'm going to use filmic just to show that we can do addition beyond 1, like it stores those values. Okay, so my point is addition just kind of combines things, right? So we had one circle, another, and now we have both of them together in kind of this peanut shape if you ignore that this area is brighter. And that's what we'd expect. So addition is kind of like an or. So this or this. Cool. What about multiplication? With multiplication, we only get the area in common, right? We only get where the left and the right circle are intersecting. And let's think about why that's the case. So in this area, both circles exist, so they both have a value of 1, which means when we multiply them, it's 1 and it shows up here. But let's say something a bit to the left over here. What happens here? Well, it's on the left circle, which means it's 1, but on the right circle, that area is just black. So focus on this area over here where my mouse is. Maybe I can, yeah, this area right here. So on the left circle, that is a 1, and sorry about all the radiator noise if you can hear it. That's going to be annoying. It's not going to stop. On the right circle, though, this is 0, because you can see it's black. 1 times 0 is 0, and that's why it kind of goes away. So multiplication is kind of like an and statement, meaning where's this and this at the same time. So just to reiterate, multiplication, can I erase this? Multiplication is and, addition is or, and I can tell you're getting bored of this video, but I'm telling you we're going to be using these concepts all the time to like say we want to combine regions, isolate them, do other stuff. This is very important. And to just understand what this math does on a per point level. So again, we're adding or multiplying or whatever at every point on the plane. Okay, so now let's try to do something a bit more challenging. Let's say we want to do this circle, but we cut away this piece right here, kind of like the Apple logo, or you take a cookie and eat it, or eat a bite out of it. Well, what we would want to do is take this and subtract away this area over here. In other words, we take this and then we subtract, set this to subtract the other circle, which gives us this. And if you're not seeing this immediately, you'll get used to it. It will make sense. And then what you have to remember is that since we are subtracting, this area over here isn't actually 0, even though it's black. It's like -1 in most of this region over here. And we can see that we should be able to see that if we do something like, we're going to put another node here, another math node, and we're going to do less than, and we want to see where this is less than 0, meaning negative. And you can see right here it's negative. But this is just very highly theoretical stuff. Okay, cool. So we know how to do and, or, kind of subtracting pieces away from each other. Let's try to combine all these ideas together for the final challenge of this video. So I have something in my nose. See if you can figure this out before I show you. What we're going to try to do is have this shape, but then subtract away the interior. So we basically have 2 moons without the intersection in the middle. How would we do that? There are a bunch of ways. Think about it. Okay, let me show you 2 methods. Hopefully I can come up with 2. So the first thing we do is we take everything, and then we also want the intersection. So let me just duplicate, Shift D, or Control C, Control V, set this to multiply, and then let's connect both of these. So we have our addition, we have our multiplication. I'm trying to show that, there you go. And then we just use subtraction, kind of like the same trick as before. So set this to subtract, and remember, we take the first thing and subtract away the second thing. This radiator, man. Take this, subtract this, gives us, well, that didn't give us what we expected. Let's think about why for a second. Okay, good. This is actually a good point. I didn't expect this. The reason why that this didn't actually take away the area from the middle, even though we did the subtraction, is remember, technically this area is 2. It's not 1. It's 1 plus 1 is 2. So we can either do some more math to fix that, or you might have been wondering what this clamp button does. And what it does is if there's anything above 1, it will just send it to 1. If there's anything below 0, it will send it to 0. So it kind of gets rid of anything that's outside the 0 to 1 range, which is normally where we like to work. So I'm just going to set this to clamp. And you're going to see now it just does our addition as if we were seeing it through the standard view transform. And now we're going to subtract it, and you can see that it works. So I'm glad that the error happened there so I could explain about clamping. So that's what clamping does on any of these. So clamping works the same for multiplication, subtraction, or whatever. Okay, so that's one way to do this. Is there another way? Of course there is. Let's try to do kind of the longer approach where we take these and I'm going to subtract, meaning meaning we take the left circle, subtract away the right circle, and I'm going to set this to clamp, which means all these negative values we were talking about are now pushed up to 0. So again, 0 to 1 range. And then let's do the same thing, but the opposite. And I'll show you a cool trick. So right now, these two subtract nodes are doing the same thing. But if we want to change the order, which will do what we want it to, you can either, do it like that, and it will flip it. We have too much stuff going on here. Let's view that. And it will flip it. Or what you can do is, instead of doing it manually, there's a hotkey for this, and that is Alt-S. And that's probably for swap or something. That's what the S is for. So Alt-S can toggle these. So now we have this moon, and then we want both of them. So how do we do that? Is it multiplication or addition? That's right, Dora the Explorer viewer, that is addition. So let's just add these. Again, doesn't matter what order, if you do Alt-S or not, because addition is, there's a name for this. It's not associative, it's commutative. I don't know, I've lost it. I haven't done math for a bit. But that's the other way to do it. So you can see we can make two different node networks that achieve the same result. And yeah, there you go. You can try to do all kinds of Venn diagram challenges with this, but really, we are going to be using these concepts all the time. Let me emphasize that. We are going to be using these concepts absolutely all the time. Subtracting things from each other and multiplying and adding. Make sure you actually understand this video. And then, after this one, now that you've completed it, we're just going to talk about how to group stuff. So basically, how I made this node over here. That's actually just a group of all these nodes. How I made that nice and compact and has one output. We're going to talk about how to set that up, and then we are going to talk about texture coordinates, which one thing it lets you do is actually make these circles in the first place, because right now we only know how to handle something that is uniform, the same everywhere. So hopefully you enjoyed this tutorial. If you did, the best way to support me is via Patreon. You can donate there, you get benefits, but really the point is, if you want to support me, that's the way to do it. Likes and subscriptions help as well, but just not as much. But yeah, one take, not bad. Hopefully you guys enjoyed this. Hey guys, welcome back to another Default Cube CG Matter tutorial, and today we are doing part 7, I think round 7, of the procedural node series, the Blender procedural nodes, and this, as I mentioned before, is going to be the last part of level 1, and from here on out we're going to get into much more complicated things, mainly being texture coordinates. So I want to congratulate you on making it this far, and today we are just going to be talking about our last topic for this, baby easy stuff, and that is going to be group nodes. And you may be thinking, okay, group nodes sounds cool, what is it? Okay, and here's what I would say to that. So here we have a node network. This should be almost, if not exactly, the same one that we did on part 3 or 4, where we talked about green screening. And what we want to do is take this node network, which is kind of, from our experience, this is a pretty big node network, but in reality, this isn't too bad. But we want to take something like this, which is a mess, and turn it into only like 1 or 2 nodes, because this is kind of disgusting to look at. And if you remember, this node network specifically does green screening. So what we did is we took a texture. So, any color background, we just happened to use green screen, but blue screen works as well. We also had an RGB node, which is the color of the background. So if this was blue, a blue screen, we'd set it to blue. And then we sent it through a bunch of math. And then finally, using this mix node, we could then pick the background. So we could have a red background or a, make it green again for some reason. But yeah, so if you want to learn how to do that, go back to that tutorial. But again, the basics were we took these two, separated them into their red, green, blue components. Again, these are 3-dimensional quantities. They're vectors, however you want to think about it. And we just separated them into components. And for each one, we just, took the difference, squared it, and then added everything together. So that's why it looks like the same for R, G, and B. And then we basically just computed the distance between these two colors, creating a matte, which we can control using this greater than node to be like, oh, what kind of tolerance do we want? And then finally, we use this matte we made as our mixing factor for the foreground, which is the image, and then the background, which is whatever we choose. So there you go. So let me just connect this. Again, Alt right click drag for that nice connection. And now what we want to do is kind of like make it one node that we can plug 2 things into. So instead of having all this math exposed, we're going to make this one node so we can plug in whatever image we want and then pick whatever color we want to do the green screening with. And without getting like too in depth to start off with. What we can do is we just select everything except our output. So this is everything we want grouped together into one node. So again, you could do box selection or you can do any kind of selection. And then you are going to hit Control G, and that is short for group. And you're going to see that, you know, all your nodes are there, the ones we selected, and there's kind of like this green background thing going on over here. And this is just to indicate it's all in the same group layer. To get out of this weird menu, you just click this button, which is go up the parent node tree. So we just click it, and now we have one node. And, you know, that's cool, but as you can tell, we've kind of lost all control. We can't even change the color of, you know, what we want to green screen out or our source image or whatever. We can disconnect, we can connect, we can even like do something in between, like, I don't know, multiply this by 2 or whatever. We can do stuff, but we've lost all control. So clearly we don't want to group everything. We just want to group everything except the inputs and outputs and all that that we want. Really, I just mean inputs. So again, if you want to look at your node tree, and again, this is a node group, you can name it whatever you want, and you're going to see if this updates. Maybe it doesn't update. In here, there should be a node group section. Here it is, node group. And you can see we have our node group. We can rename it to, like, this is our green screen node group, and it's going to update here. And this is useful. I need to make sure my face cam's out of the way. This is useful because if you make a bunch of node groups, you can then send them over to your different Blender projects, and that's how you don't keep repeating the same thing over and over and over again, so you only have to make it once. So that's part of the powered node groups. But to look into this node group, you just hit this button on the top right, you click that, and then you can see everything on this layer. So let's get rid of this node group. You can either right click and then do ungroup, or shortcut is Control-Alt-G, and you then have to just move it over. Okay, so now we are pretty much where we started off. But now we want to do this a bit better. So let's think about this. What do we not want in our node group? And so what do we want to be able to change later outside the node group? Well, we want to be able to change, again, what we're inputting. We want to be able to change the color. So let's start with that. So let's say we select everything except those. And then we're going to hit Control G. And then we're going to go up the parent tree. Well, now we have a node group that actually has inputs, and you can see it has 2 inputs for the texture, one for you know, just choosing the texture, and the other one goes to the mix node from before, and then we have a third input, and that is the color of our background. But now what we can do is we can change the image. So I'm going to take this texture, and I'm just going to choose the second image I have. Now, since this has a similar green, it should work. Whatever color we chose over here, but again, you can try to fine-tune this. So let's switch to RGB, and you could, like, you know, you can see that you can do different green screen stuff. So this is our green screen node, and then we can plug in any 2 things over here. But of course, there are a couple issues. First of all, why do we have 2 inputs for the same thing? I feel like we could do it with 1 input. It'd be different if there were like 2 different image textures, but because of the logic of our node group, we want this input to go to both. And second of all, we want to have a bit more control, like that greater than value that'll let us pick what we want in and out of our matte. We'd like control over that as well. So wait, first of all, before we fix those things, let me see if I can pick the best shade of green. Remember, we can use this eyedropper. And now, let's delete that. Yeah. So, for example, we do want that greater than value, so we can control that. So I'm just going to Control-Alt-G, that is ungroup, and try to reorganize everything. There is an add-on as well, other than a Node Wrangler. I think it's called Node Arrange. That should handle stuff like this, but let's ignore that for now. So the first thing we want to take care of is not having to have like 2 inputs just for this image texture. And you can see it's because it has 2 wires going to different spots. And I don't think I talked about this yet, but we can actually use something called rerouting. And the way you do this is not Control right-clicking or Shift right-clicking, but, it is Shift right-clicking. I was trying to say not Control right-clicking or Alt right-clicking. So you hold Shift, right-click, drag over any 2 or 3 or however many wires, and you're going to see that it creates a reroute, but actually connects them. So basically, we have our color going here, and now that one is what branches off into 2. So if we group everything, including this reroute. And again, you could just, by the way, you could just type in reroute and add just this node here that you can add to different areas. And this is just for like a graph organization if you just do it on one wire. But what we're going to do now is we're going to select the same nodes as before, but then also our reroute, and then Control G, and let's go up the parent tree. And now we only have one input for our image texture and one input for our color that we want to green screen. Okay, cool. So how do we make this even better? Well, first of all, maybe you're sending this node, you're selling it or whatever. You want some better names here. How do we do that? So this is just organization stuff. So in here, you click N for properties the same way you click N up here. It's a window dependent. So this is what happens if you do it in the shader editor when you're in a node group. And you can see we have our inputs, our outputs. So make sure you're on this node tab over here. So you can see we have our inputs, all the names, and then our outputs. And if I haven't already mentioned it, you can see once we're inside this node group, basically you can see we have our two inputs, which are really from out here in the background. So you plug stuff in to this node group, and it comes out here, does its stuff, and then goes to the group output. So normally we do nodes to the material output node, to the surface socket, or whatever. But here inside a node group, the name of the game is you start with your group inputs, do the stuff in between, and your group output. So what I'm going to do is change the group input name. So let's just select the first one. And the first one is actually, you can see image is going down here, and this is the one that we actually choose the color of our green screen. And I want this to first of all be the second option, not the first. So I'm just going to click it and then drag it down, or just use this up and down arrow. And then we can rename this to maybe keying color, you know, what color you're going to key out. And then for this input, we can choose, let's just say like input's actually pretty okay, but let's do input image, something like that. So now these are renamed. It doesn't change anything, but it just makes it more organized for the viewer if you send this to somebody. And then you can also see we have this default value, and this is going to change depending on what it is that you're doing here. So here we have colors. You could also have values or vectors. So this default value is basically what it's going to be when you don't connect anything to it. So what is it going to be by default? So for example, with a math node, you can see that by default, these are 0.5. There's no reason this could not have been 0, but it's because Blender chose 0.5 as the default value. So for the keying color, maybe it would make sense to, you know, I guess it already has this kind of green. Let's just do blue just to illustrate a point. And now when we go up our tree, we have our renaming. And then I'm just going to disconnect everything. And then normally you have to actually re-import in the node group before the default values refresh and everything. So you can either do that by, you know, Shift-A. Now that this thing exists, you can type in the name, which I think was green screen. And you can see now it shows up. But I guess this was our first node group before we started messing with stuff. So the second thing you can do is go down to group, and it will list all the node groups you made. So I think it's probably the newest one. And now you can see it has its default values inherited, and blue is what we set for default. But, of course, what we can do now is just connect what our input image is. Let's make that a bit bigger. And then our keying color. And let's connect that to our surface. So there you go. And let's actually do a bit of cleanup. So in our node groups, I said if you don't have all these options, go here and choose Blender file instead of, I don't know, you're probably on view layer. Blender file, this again lets you delete stuff from the file itself. So let's delete our green screen node group, our node group, and we can rename this one. We can rename this one to like green screen final. And you can see it changes the name over here. And now we said we wanted a couple more things. I think the main one was actually adding a value input for our greater than. And again, if we go into here, our greater than is this one right here, and we want to control this number. And you can see why we would want to do that, because before we had it somewhere here, and there's a bit of clipping. But if we just drag this down, it actually solved the issue. So we like control over that. So normally what we do is if this wasn't in a node group, we just put a value in here and just connect it so we can kind of control this externally. But of course, we're in a node group, so what we want to do is for this, we want to use something from our group input. And again, we want to make a new one, so you can see we have our two inputs, and then a blank slot, which is for adding stuff. So what I'm going to do, is I'm going to take this, the third one in this case, and connect it to greater than. And you can see effectively this added a third input, and it automatically knew it needed to be a value. Again, that's like a one-dimensional. It's just a number. It's just a value, and it's not a color, which is like almost the same thing as a vector. So it automatically recognized what it needed. And then for our value, we can give it a name, something like, threshold would be appropriate. And again, for this one, the default value stuff gives you even more control. So first of all, we can choose what default value we want. So let's say 1 when you don't connect anything to it or you don't specify what you want. And then the second thing is, if we kind of exit out of here, you see that this already gives us a nice slider that we can control, and it does, what it would have done if it was connected to the greater than node. But you can see we can kind of go negative, positive, and in this case, there's no reason for us to go negative, so we can actually clamp. We can make a cutoff. So we don't want somebody to scroll beyond 0, so we don't need negative numbers. And then for maximum, I made a mistake in that tutorial. I said you wouldn't want to go above 1 because the distance between any two colors can't be greater than 1, but that's not true. It's actually square root of 3, which is kind of obvious once you look at it from the sense of this equation, because you can have a maximum distance of 1 between your red values, green values, and blue values. You add those square root of 3. So we wouldn't want to go above square root of 3, which is like 1 point something. So let's say 2 is the highest you can go. You can get more accurate. I wonder if you can actually type in like square root of 3. Oh, apparently you can. So there you go. And now, let's see, do we need a refresh? No, you see it doesn't go, I'm trying to go left, it doesn't go under 0. If we type in -1, I guess you can't override that, but there you go. Or you can override that, that's the issue. And then we can't go higher than square root of 3. But now we have control over this, and it has a nice name. And then finally, probably the last thing we need for this one is for our output. And by the way, you can have multiple outputs for a group node. In this case, it doesn't really make much sense because what we'd want to output is our image, but I'll actually add another one just for demonstration. But we can rename our color output, and again, default values and everything. You know how that works now. So let's call this keyed output or something, because that's what it is. And you can see, just like our group input, we can have more outputs, and that will specify what it is when we actually make it. And maybe it'd be interesting to also output our matte. And this is just the black and white image that we're using as a factor. So I'm just going to connect this. Automatically knows it's a value, not a color. It's a black and white. It's just a number. It's a one quantity. And we'll call this our matte. And this is something actually that's kind of realistic that you do. So let's, in this case, default value and all that don't matter because it's going to be determined by this math. So let's go out. And you can see now we have, we can change this. I'm just going to go back to our, I guess we don't have to re-import it that way. We can just select it from here. So green screen 1. And then just to make sure, I'm just going to view this and then select the shade of green I want, just in case it's a bit different. So again, we can do all that, and we have our group node and everything's nice, but then we can also view our matte, which again is the black and white image, and maybe we want to do something with that. I don't know what it'd be. Maybe we could do something like this. So now that we've done all the calculations, we can send this now through a mix RGB. We're going to set this to multiply, let's say. And we haven't really talked about what all these blending modes do, but right now I'm not too worried about it. So we're going to set it to multiply, and let's have it multiply. I want to only have the background, so remove the person. It's going to look like black where the person is and then blue elsewhere. So let's multiply it by the matte, I believe, and then we have to invert it. Is that right? No, I'm going crazy. Let's see, what does this look like? Yeah, I think that should be right. I don't know why it's not giving the, oh, there we go. It's because of this mixing factor. So once we have a mixing factor of 1, it's just going to do the multiplication how we'd expect. And without too much explanation, because this is a group node tutorial, what's happening is we already talked about math with regions, so you should now understand this. What we're doing is we're taking our image and then multiplying it by this, where anything in here is going to get multiplied by 0 and therefore be black, 0, and everything here is multiplied by 1, meaning it's going to be whatever value was before, so it just retains whatever color that is. If this was 2, right, in the background, it'd be like a brighter blue in our output. And I guess we could do that just to, again, prove a point. Now, I don't think we're going to see this currently because of our color space. But I guess, you know, you could do values in between, and that controls the brightness of the blue. So if we want to, are we already in Filmic? Standard, I guess it does work. So there you go. I feel like you now know everything you need to know about group nodes, and if we were to go to a new Blender project, what we'd have to do is, let's say we want our green screen node, you go to F3 or spacebar or, you know, file append, but I'm just going to type in the command append. And then you just want to choose the Blender file you just worked on. For me, that was Untitled. And then you're going to find either in materials, you know, we have our green screen material, or like we don't need the whole material, we just need the node group. You can go to node tree. And then you can see our green screen final, and you append that. And now in our new project, that again, this is independent from our previous one. Now if we go to group, we also have our green screen, and you know, it's a nice looking node. This is something you could sell for, like, nobody would want this, but you know, it's a good example. So now you understand everything there is to know about group nodes, how it helps you organize, how to control your inputs, your outputs, and, you know, append and all that. So you guys made it through level 1. Congratulations. This is where it starts getting really, really mathematical. People will tell you that, you know, you could learn nodes without math. Anybody? No, you need math. The math happens to be pretty simple in most cases, but this is where the math starts laying on. Not too badly. I think the next thing we're going to do is probably just make a circle that we can control. But yeah, there you go. Hopefully you guys enjoyed all the tutorials for level 1. I think I'm going to upload this as one segment of the course, so I'm just going to make a compilation video. But the best way to support me now that you made it through level 1 and you've gotten your free education is via Patreon. So if you appreciate the series and want to effectively, you know, donate to me, but then also get some benefits, and there are some nice ones. There's some hidden information you'd only know via Patreon right now. If you want to do that, there's a link in the description. It'd be very, very appreciated. But other than that, thank you guys for sticking through level 1. There were 12,000 of you to begin with as I'm recording this. Losers are out of here now, and now we're down to like 6,000 or 5,000 or something. So you guys have made it past this threshold. We'll see if you make it past level 2. Thank you guys for watching. That's it.